Analyses have been performed by means of the software MUSIAC, Multi-Scale Impact and Crash, which allows to use multi-body models interacting with finite element models in the same integration loop. MUSIAC is largely based on the experience of EDIAC, which was originally developed in the 1980s and subsequently widely used for barrier design. In MUSIAC, multi-body models are used to approximate continuously deformable structures as the barrier or the body of a vehicle. A multi-body model is composed of a number of discrete masses or rigid bodies, incorporating all the inertia properties of the structure. Such masses may be connected by deformable elements representing all possible deformations, i.e., elastic, plastic, up to failure or complete detachment of a part. The contacts and the contact forces between the different parts of the models, which are essential in the analysis of a crash, are generated by discrete contact surfaces. Each contact surface may be connected to one or more masses, which determine the motion of the surface itself and receive the contact forces generated by it. In MUSIAC, contact surfaces may be polyhedrons, cylinders, and other surface of revolution. The model for the 900 kilo car and for the 38,000 kilo articulated heavy vehicle were taken from the library of MUSIAC. The vehicle model library includes all the vehicles specified by EN 1317-1 to be used in barrier tests. Such vehicle models have been validated through the comparison with a large number of full-scale tests and are currently used for safety barrier design and test prediction. The multi-body model of the complete barrier was developed ad hoc, making use of the results of more detailed finite element analyses and of laboratory tests on components. The measures of severity indices and a working with were obtained from the MUSIAC analysis on the complete barrier vehicle road system.